When you think about volcanoes, it's a pretty safe bet you don't think about Florida, but perhaps you should. Some of the world's leading volcano researchers are right here at USF School of Geosciences. When Mount Momotumbo in Nicaragua erupted late last year, they were among the very first scientists on the scene. Momotumbo has a history of violent eruptions. In 1605, the original town of Leon was destroyed some 30 miles away. The late 1800s saw at least 10 eruptions, but it has been quiet since 1905, and so scientists did not have monitoring equipment in place when it blew early last December. But what triggered that eruption?
The volcano behaves almost like a bottle of soda with a lot of gas in it, and it shook a little bit and exploded.
It may have been nearby earthquakes in the months before that caused the volcano's built-up gases to roar to life. The USF team arrived just a few days later.
When we got there, actually, it was quiet, and we began setting up some instruments. And a few hours went by, and then suddenly it had a small explosion. By small, I mean it sent Volkswagen-sized blocks cascading down the flanks of the volcano, setting forest fires and sending a shockwave across the countryside. So it was a big explosion, not so big as far as volcanic eruptions go, but spectacular nevertheless.
Grad student Liz Gallant will soon be returning to Momotumbo for more radar studies.
There have been a couple more eruptions, not as much lava activity, but more explosions, and we want to see if there are any changes that we can measure with that instrument. It'll tell us if it's inflating, if it's deflating, if there's any deformation associated with it, and that can tell us kind of about the health of the system below where we can see with our eyes.
Florida may seem an unlikely place for a team of world-class volcano researchers. There are, of course, no volcanoes in the Sunshine State, but they have recently begun studying an explosive force right here in Florida, and it mimics the power of a volcano.
A rocket is like an upside-down volcano, so we didn't get these infrasound sensors very long ago. We wanted to go to a place where we could put them all together, and we could record an event that would produce infrasound. Now, we don't know when a volcano is going to erupt, and there's none here in Florida, but there are rocket launches, and we know exactly when they're going to take place.
Lava flow is another area USF scientists wanted to research. They want to learn more about how lava behaves as it cools, and they needed a way to study it in the lab. The answer? A kiln and glass heated to 2,000 degrees.
Volcanic eruptions are rare. It's very hard to go see a lava flow or see a volcanic explosion. Glass is a silicate. It's a silicate melt, and magma is a silicate melt. That means they behave roughly in a similar fashion. So we can use hot glass to mimic the properties of lava, for example. And so we can see how volcanoes might behave under different circumstances, but control those conditions.
Although USF volcanologists don't forecast eruptions, their data helps other scientists to better understand volcanoes and possibly to warn people before an eruption.
I've seen eruptions which have killed tens of thousands of people, and that's horrible. And I would like to do research that helps us prevent that kind of catastrophe in the future.
Professor Chuck Connor now joins us on set. Professor, welcome to University Beat.
It's good to be here.
That must have been so amazing to see that eruption in person. Describe the experience.
Yeah, it got our attention. We arrived in Nicaragua, and within 12 hours we were on the volcano. We were setting up our gear, and suddenly we heard an explosion. And Volkswagen-sized bombs were flying through the air on the volcano, setting forest fires. A big gas plume rose over the volcano, and we were able to see that at a safe distance, but it was spectacular.
Is one eruption from a volcano different from another?
Absolutely.
How?
Some volcanoes effuse lava flows, and those are spectacular and are hazardous to people living near the volcano, but basically it's just a beautiful show that nature puts on. And then others are explosive, and those are much more dangerous, and those volcanoes have far-reaching effects. So we definitely want to know the difference between a volcano that's going to erupt lavas or one that will explode. And the same volcano can do it, either type of activity at a different point in time.
We're used to having hurricane experts in Florida, but it's unusual to have volcanologists in Florida.
Basically USF is a global research university, so we want to solve global problems, and volcanoes are a global problem. People who live nearby are at risk from the volcanoes. Their lives are at risk, their economies are at risk, but volcanoes also have worldwide impacts, so we want to understand those as well. So even though Floridians aren't affected by volcanoes directly, we don't have to worry about the lava flows coming here or anything like that, but our climate is affected by volcanoes, our economy is potentially affected, so we're part of the global community. We need to know what's going on.
Why do you make a distinction between predicting, in quotes, a volcano eruption and forecasting a volcano eruption?
Right. Prediction has a lot to do, with certainty and being sure you're able to say when the volcano will erupt. And we're actually not able to say with certainty when a volcano will erupt. So like a meteorologist, we make a forecast. The meteorologist will say, there's a 30% chance of rain tomorrow, and you understand what that means inherently, that there's a chance it'll rain, there's a chance it might not. And that's what we have to do in volcanology as well. We have to forecast eruptions, and when the probability is high and we're relatively sure, then people respond.
Do you think we're getting closer to the day in which we might be able to predict a volcanic eruption?
Well, we're getting better and better at understanding when volcanoes will erupt, mostly from improved monitoring networks, both from space and on the flanks of volcanoes. So some volcanoes are very well monitored, and people can forecast eruptions, sometimes to the day, with pretty good accuracy. But there are big questions we haven't answered yet. So for example,
like
well, it's hard to know how big a volcanic eruption will be. One level, if the eruption is small and it erupts, that's good for business. It's good for tourism. People come and look at it. On the other hand, if the eruption is large, it can be quite dangerous and it can potentially kill a lot of people. So we want to be able to forecast the magnitude of the eruption, and so far we're not so good at that. We're making progress, but we're going to do a lot more science before we can make those kinds of forecasts.
Dr. Connor, thank you for being on University Beat.
It's a pleasure.